We have another inverse problem for page, what is this, page 5, number 14. We're told that f and g are differentiable, and f of g of x is equal to x, and g of f of x is equal to x. In other words, f and g are inverses. They don't specifically tell us that they're inverses, but they're giving us the clue to draw the conclusion that the functions are inverses. All right, so f of 3 is equal to 8, and f prime of 3 is equal to 9. What are the values of g of 8 and g prime of 8? Okay, so quick and easy right away, if f of 3 is equal to 8, we know that g of 8 is equal to 3. That's the rule for inverses. So right away we can eliminate A and B. All right, but we do see that we have 3 choices left. And in order to find g prime of 8, all right, well, that's equal to our inverse rule, or inverse derivative rule, rather. That's going to be 1 over f prime of g of 8. All right, and g of 8 is 3, so this is equal to 1 over f prime of 3. But f prime of 3, we're told, is 9, so this is 1 over 9. And we see that the answer is right here with E, so E wraps up number 14. Okay, 15, we have arc cosine, so now we're into inverse trig. Okay, so in general, let me put it up here a little bit just because it's off. So the derivative of arc cosine of x, just x, is negative 1 over root 1 minus x squared. Now we have an inner function here of x squared, so as we perform this chain rule, all right, the derivative, so we're going to derive the outer, which is arc cosine, and again, x squared is our inner. So we derive the outer, so that means I've got this negative 1, and then I've got square root 1 minus something squared. All right, there's deriving the outer with respect to the inner. So the inner function is x, so I've got x squared right there. And now I'm going to multiply that by the derivative of the inner function, and the derivative of x squared is 2x. Now obviously we don't see this as any one of our 5 options, but we can simplify it ever so slightly. The 2x can move up into the numerator, so we have negative 2x up in the numerator, and right away that tells us our answer is B. But as we go a little bit further, 1 over 1 minus x squared squared is x to the 4th, and that just confirms the answer is B. With 16, we see inverse trig, but we also have implicit differentiation. All right, so what's happening here? Well, we derive the left and we derive the right. The derivative of the left side of the equation, arc sine, derives to 1 over 1 minus x squared. And then on the right side, we have the natural log of y. If this was the natural log of x, that would become 1 over x. This is the natural log of y, so it will derive to 1 over y. But because we derived a term with respect to y, or with respect to x, and it's a y term, we need our times dy dx. All right, so we need to get dy dx all by itself, which actually isn't all that bad this time. We just need to multiply by y. All right? But whatever we do to one side, we do to the other, so dy dx will be equal to y over root 1 minus x squared, which is option A. And then 17, this is a doozy of a problem, it looks like. We've got to find the derivative of f of natural log of x if f of x is equal to that polynomial right there. Okay, so f is the outer function and log x is the inner function. All right, 17 problems in, you're getting the idea of what these questions are presenting as the College Board gives them to the students. Okay, so what's going on here? This derivative, so we derive the outer, so that means f will become f prime with respect to the inner, so log x, and then we multiply that by the derivative of the inner function, and the derivative of log x is 1 over x. All right, and so what's going on here? We have to plug the natural log of x into f prime. So we'll go over down here for a moment. F prime of x, that's not too hard. That's just going to be 2x plus 2. So f prime of log x, which is what we need, we're just going to replace x with log x. plus 2. So there is f prime of log x. So let's write that. 2 log x plus 2. And we multiply it by 1 over x. Multiplying by 1 over x is the same thing as dividing by x. So it looks like our answer is A.